So in this part of the question, it says that a 110-volt DC supply is connected to a heater, a fuse, and a switch as shown. Owing to a fault in the system, power is not supplied to the heater. That means there is no current through the heater. A technician diagnoses a fault using a voltmeter. He closes the switch and connects his meter between the positive supply terminal as positive, so here, and the fuse terminal F2. So if you try to have a look at that, that is this pot and this. So essentially what he's doing is connecting a voltmeter across these 2 points. That's going to be looking something like this. That's the voltmeter there. And the voltmeter reads 110 volts, so that's the entirety of this 110 volts. So which diagnosis is correct? So before looking at the answers, we can dig into a bit of theory. So if this pot is showing 110 volts, when does a voltmeter show a reading? A voltmeter shows a reading when there's a potential difference. That means that there is a drop, there is a compilation of charges, right? If your current can actually easily flow, there is no resistance, there is no reason that the voltage will drop, right? So the potential difference is essentially what the voltmeter measures, right? The voltmeter is responsible for measuring the potential drops, and the drops in potential occurs only due to resistance, and that is essentially the current is not being able to flow when you have got a very large resistance, right? The current is not able to flow properly, and therefore there's a lot of work done by the unit of charge. There's extremely high resistance, and your current is not able to flow. So in this scenario, you're seeing that the entirety of the 110 volt is seen in this part of the circuit. The heater is not getting any potential drop. That means there is no current that's actually flowing through the heater. Over here, all of the voltage is being dropped over here, and why is that the case? Because current is not able to flow. The current is actually getting compiled right over here. It's getting compiled, so that's the compilation of charges, right? And charge is not able to flow to that part of the circuit, this part, so that there is like so much here and there's nothing here. These are all the charges Q, and since current is not able, the charges are not able to flow. Why are the charges not able to flow? Because of the fuse right here, right? If this was a normal fuse, the resistance would not be high, so essentially we would not expect any voltage drop in ideal scenario, especially in A-level questions. But here we are seeing a massive voltage drop. That means that there is the compilation, or like the storage of charges here. Charges are not able to flow to this part of the bridge, you could say, and that's because of the fuse. So essentially, that means that the fuse actually has melted. Okay, so this fuse here, this has melted, and because this has melted, you're making an open circuit, right? The charges are here and they're not able to flow here. So essentially, definitely, the correct answer is A, the fuse has melted, but let's see why the others are wrong. So base test, the fuse has not melted and there's a short circuit in the heater. Well, if you do have a short circuit in the heater, that would actually not cause such the 110 volts to be dropped across the fuse. The fuse would perfectly be intact even if there was a short circuit in the heater. That simply means that there would be huge amounts of currents in the circuit itself, but that's not going to cause the fuse, but that's actually also going to be causing the fuse to melt, if you know your thing. But this third part is like there's no path for current through the heater. Well, if there's no path for current through the heater, that would mean that current is not able to flow through the heater, like charge is not able to flow. So essentially that would cause a voltage drop, a massive voltage drop across the heater. And this part, and the switch has operated correctly. Well, if everything was going all right, it's not melted and was operating correctly, that would mean that it's working fine, but we know that the heater power is not supplied, so there's no current through the heater because all of the charges are getting compiled here. They're not able to go to the heater. They're getting stuck over here because the fuse has melted. So essentially the answer is A.